All right, now for our new material on day what? Day 7 of inheritance. We've done overriding and shadowing recently. And now we come to the cosmic superclass and the creation of objects. We'll start with the creation of objects since I already have my classes all set up, ready to go, and you do too. So I'll be lecturing on points A, B, and C here. I'd let him do it, but I don't like his variable names, SBC and SPRC. I like super and sub a lot better. But hopefully mine's a little less cryptic. All right, so we've made these objects in the tester. Super super 1 equals new super, and super sub 1 equals new sub. We can also do this. Here's what's new. We can say super S1 equals new sub. You will see this throughout the AP exam. They'll put the big class on the left. That big class in this lesson is a superclass. The big class in about a week is called an interface. Okay? It's kind of like doubles and ints. When you think of doubles and ints, which one do you think of as a bigger class? I always think of double as a bigger class because it can hold more. If I have int x equals 4 and double y equals 8, I can say y on the left equals x on the right. You know that works fine. But I cannot say x equals y. An int just cannot hold the range of numbers that a double can. That's our incompatible types error. Think of double as a super and int as a sub for now. I think you'll be okay today. Now, there are rules here. And the rules are kind of tricky. I'll go ahead and call my hello method like we were doing earlier. I've got super on the left side of the assignment operator. I've got sub on the right. We compile it. We proved it's legal. Now what happens? I mean, to the beginning programmer, first time seeing this, well, I see that S1 is a super over here, but then over here it's a sub. I wouldn't bet my pinky on which hello it's going to call. So we'll discover it. We'll run it. And it calls a 1 in the subclass. Okay, here is the black and white rule. The method we call must be in the superclass or it won't compile. Okay, that's the first half the rule. The method we call must be in the superclass. Again, next week or so, it must be in the interface. But all we have now is superclasses and subclasses. So let's prove that, right? Let's control X, the hello method in the superclass, which it didn't even run, right? It ran, what did it do? Do you remember what it did? When I ran tester, it ran the method in the subclass. Do you see why it's hard? This rule does not make sense at first, does it? We're not even going to run the one in the superclass, and yet Java won't compile if the method's not there in the superclass. What's it say? It says, I can't find hello. Well, you just found it, Blue Jay. You just found it, Java, 2 minutes ago. What do you mean you can't find it? Do you see why it's hard? The first half of the rule is it's got to be in the superclass. So I'll go back up there, put it back in, and now it compiles. The other half of the rule happens at execution time. So this first half is for compile time. Will it compile? If it's in the superclass, it will. Now, at runtime, Java will look for the method in the subclass. If it's not there, it will look in the superclass. See, the compile time problem is not really consistent with the runtime problem. It doesn't really make sense to us yet until we really get into this. So, compile it, run it, of course, you know what happens. Okay. It doesn't need to be, of course, in the subclass. That doesn't violate any rules. Okay. The last part of this is just like trying to say an int is equal to a double. You can't do this backwards. You can't say sub s2 equals new super. Just like we can't say int x equals a double y. That won't compile. Okay? You cannot convert this sub from into a super. So again, this is all here in this little chat part called creation of objects. I just didn't like his variable name, so I didn't use his lecture.